So let's do an example where it does converge. Example. So let's say that you wanted to calculate the integral from, let's do 1 to infinity of 1 over x squared. Okay, so remember, 1 over x squared looks a lot like 1 over x. Looks something like this. And you are accumulating the area under it from 1 off to infinity. Okay, so what we're going to do is we're going to turn this into a definite integral. This improper integral from 1 to infinity is the same thing as the limit of the integral from 1 to b of 1 over x squared dx. Now, how do you make them equivalent? You let b go to infinity, right? That's like the crucial thing here. So what you're doing is you are rewriting your improper integral as the limit of a definite integral. Why? Because we know how to calculate the definite integral, right? You can use the fundamental theorem of calculus. So looking at this, you're like, oh yeah, well, my antiderivative for 1 over x squared, so if your f of x is x to the minus 2, when you use the fundamental theorem of calculus, you'll get minus 2x, wait, antiderivative. Doing the derivative. It'll be n plus 1, which will be x to the minus 1 over minus 1, which will be minus 1 over x. Yes? Did I do that right? I'm not trusting myself right now. The antiderivative of 1 over x squared is minus 1 over x. Yeah. Okay, so now this is going to be equal to the limit as b goes to infinity of f of b minus f of 1. And now we can like plug all that in, so you're going to have the limit as b goes to infinity of, well, if you plug in b, you're going to get minus 1 over b minus, if you plug in 1, you get minus 1 over 1. So let's simplify. Those double negatives will become plus 1. So you're going to get minus 1 over b. Limit as b goes to infinity. Yeah, I'm doing this right, man. Yeah. So as b goes to infinity, what do you get there? What does negative 1 over b go to as b goes to infinity? What happens to that value? This one right here. Yeah, 0. This part goes to 0. So the whole limit becomes 1. Which is sort of interesting. What does that 1 mean? It means that this infinite area here has an area of 1 unit. The infinitely long region, because it goes from 1 to infinity, has area of 1 unit squared. Because that's what, right? Because the unit of area is units squared. Shit, sorry. I'm struggling making words. Okay. Which is sort of weird. Like, if you keep on accumulating area under 1 over x squared, somehow the area is 1. But what's the creepier thing? The area of this is 1, but what happened with the other one? If you think back to what we were talking about. What happened when we tried to accumulate the area under 1 over x? What did we get? Does anyone remember? No, it wasn't 0. It was what? Does not exist, but importantly, it does not exist because what did that value trend towards? The limit of that value was like, it wasn't an actual number. What was it? Like, you can say that it doesn't exist, but like, why did it not exist? Because it was going to infinity, right? So this is the creepy thing. 1 over x, if you accumulate area from 1 to infinity, that's an infinite amount of area for this infinitely long thing. But if you accumulate it for 1 over x squared, it's infinitely long, but how much area does it have? 1. It has a finitely sized area spread out over an infinitely long distance. Whereas this one has an infinite area spread out over an infinitely long distance. That's like what you should realize is really weird about this. Like, that's, yeah, it's weird.